Welcome back to EV channel. So today we are going to discuss about the environmental impacts or effects created by the electric vehicle on the GENCO. So GENCO means energy suppliers. So if we keep on increasing the availability of more EVs are coming into the market, our power system cannot handle this more EV penetration. So what will happen to power generating companies? What techniques our power generating companies has to employ, like microgrid, like smart grid, like solar system charging, the power generating companies has to implement. Okay, let's try to have a review of this. So that's why this is called environmental effects. So what are the effects created by modern drivetrain? What is meant by drivetrain means an electric vehicle is called as an drivetrain. Why? Because electric drivetrain will try to drive in the forward direction or backward direction. So those are called as drivetrain. In technically, I'll give you an clarity what is meant by an drivetrain. Drivetrain means it is called as an group of powertrain. Powertrain means this is a train which runs with battery and an motor with an energy source and energy converter. If anything runs, it is called as powertrain. Like this, more powertrains are available or group of powertrains are available, it is called as drivetrain. In overall meaning, powertrain or group of powertrains is called drivetrain. Overallly, what is meant by drivetrain? An electric vehicle. Okay, so what are the environmental effects created by an electric vehicle on whom? Energy supplier. Who is going to supply the energy? Generating companies. So what are the problems created by this electric vehicle to the power generating companies? Let's try to discuss each problem. So what is the type of impact or what is the type of effect created by the EV, and what are the problems associated with it, and what are the possible solutions? Okay, first we'll discuss about the effect created, what are the causes creating that effect, and what are the possible solutions. So like this, you have 6 problems, 6 causes and 6 solutions. Okay, let's try to discuss about first one, voltage instability is called voltage fall. So whenever the load is increasing dangerously or the load is increasing, automatically the voltage will fall. Why the voltage will fall? If everyone is buying electric vehicle around, now the electric vehicle percentage is only 5%. It has been increased from 5% to some 30%. The load is increased. The load is increased, what will happen? Electric vehicles will be continuously charging in the power line and continuously they will be discharging. The way it charges is called as a grid to vehicle. So when the vehicle is charging, it will take the power from grid to vehicle. Whenever it is discharging, it will deliver the energy from the vehicle to the grid. So this simultaneous process of grid to vehicle charging and vehicle to grid discharging will increase the load. Okay, that is called as charging as well as discharging of EV batteries will create an voltage instability in the existing power system. So what are the solutions is, you should have an automatic tap changer or manual tap changing setting should be continuously made at which level? Substation level. Substation people should automatically adjust that tap setting or the tap changer to maintain this in voltage instability, to maintain an proper voltage of 230 volts or 415 volts for single phase as well as 3 phase. And next one, fuzzy logic based voltage control. So rather than using manual voltage control technique, we have to use more automated voltage control techniques like fuzzy logic based voltage control techniques, where all these 3 methods will try to maintain required amount of constant voltage as 230, as 440 whenever the electric vehicle is getting charged or whenever the electric vehicle is getting discharged. Now, third one is taken care by power system modeling. We have to improve our existing power system to an latest power system like smart grids. Although we don't have at least microgrids here, so we have to improve our power system with smart grid technology. So we can charge electric vehicle at any place. We can use your electric vehicle like an battery also as an one more grid also. Okay, so that is also be possible only when you have an smart grid. Indirectly, we have to improve over the technology what is there now. Why? Because technology is outdated, but electric vehicles are more advanced. So due to induction or due to implementation of this more electric vehicle, they will charge with faster rate and they will discharge with slower rate, which will create an high volt. They will create an high loads. Why? Because each electric vehicle will be minimum how much? 30 kilowatt. In our campus only 30 kilowatts, around 10 vehicles are there. How much it is? It is around 300 kilowatt load will be there. All the electric vehicles are connected at 9 o'clock. 300 kilowatt load is there. Automatically, what will happen? More load is there. If the more load is there, automatically voltage will fall down. So the nearby substation, they should adjust the tap setting. The nearby substation should improve their technology. They have to use fuzzy logic based voltage control technique. Or the nearby substation to go with smart grid. Or complete transmission corporation has to go with smart grid technologies, where we can charge, you can discharge an electric vehicle at any point. So this is the voltage instability problem, effects, causes, as well as the possible solution. Next one, harmonics. So why these harmonics are available due to electric vehicle? Basically, electric vehicles are of a non-linear load. Why? Because they are of the chargers are all of inductive nature. At a time, how many kilowatts they'll take to charge a four-wheeler? 30 kilowatts. Therefore, suddenly they consume the more amount of power, and we are using uncoordinated charging of VV. What is uncoordinated charging VV? You should charge your electric vehicle only when there is no demand. When there is no demand on the power grid, at night time. So we should charge your electric vehicle only at which time? Night time. You should not charge your electric vehicle at which time? Morning time. So people don't know this formula, and they'll charge this electric vehicle at morning also. So at morning there is a full load from colleges, from industries, and from the public. Automatically electric vehicle also is creating an load. Automatically the power system will collapse, and which may lead to the development of a lot more and more instability problems, or lot more harmonics problems. Okay, you should use which type of charging method? Coordinate charging method, and you charge your electric vehicle only at low peak hours. When you have low load demand. When you have low load demand at night time, then you can charge your electric vehicle. Next one, use an charger which consists of pulse width modulation. The chargers, we have AC charger, DC charger. They consist, we have to use latest charger which consists of more pulse width modulation. Automatically the harmonics can be eliminated. So harmonics will not be injected back to the source. So harmonics are developed by the source. Harmonics are developed by the load. From the load they will come to where? Source. So who is the origin for harmonics? Load. Now who is our origin for harmonics? Electric vehicles. Electric vehicle chargers, charging the electric vehicle at morning time, increasing the voltage sag and voltage instabilities will create all these harmonics and voltage instabilities. So we have to use the best pulse width modulation techniques in pulse width modulation. We have to use pulse width modulation technique in all the modern chargers available. Next one, use active filters as well as passive filters. Already you studied how to arrest or how to regulate these harmonics by using active filters. Active means they only will generate some harmonics, and they will suppress the available harmonics. Passive means they directly absorb the available harmonics. Okay, so those are called active filters as well as passive filters. By using active filters as well as passive filters, you can suppress the effect of harmonics generated by an electric vehicle. Next one, by using proper pulse width modulation control techniques used in an electric vehicle charger can also be suppressed the harmonic generated by an electric vehicle. Actually, who are generating harmonics? Source or load? Load is generating. This load is affecting whom? The power generating companies. That's why all these are the effects or the problems created by electric vehicles. So up to now we have been studied, we have to have an innovative technology of buying an electric vehicle. But if you buy more electric vehicle, our department should be ready to accept this electric vehicle change. They should optimize, they should improve their technology to microgrid or smart grid. If they are not improving, this will create problems like voltage instability, harmonics, voltage sag, power loss, overloading of transformer, and power quality degradation. All these problems will be created if you inject more electric vehicles into the market. So before you inject, you should optimize your substations, you should optimize your power grid to an which type of system, like microgrid as well as smart grid. In foreign countries, we don't have our SAS system, they have the latest smart grid system or microgrid system. So this technology can handle all the power quality issues created by an electric vehicle. So this can be mitigated by using coordinate charging. What is coordinate charging? Charge electric vehicles only at non-peak hours and use pulse width modulation technique for the EV chargers to reduce the effect of harmonics developed by the chargers. Use active filters and passive filters at load side, which can eliminate the harmonics in the power system. Therefore, the power generating companies will not struggle. Next, voltage sag. What is voltage sag means? Voltage dip or fall in voltage is called voltage sag, or fall in voltage magnitude is called voltage dip. Why this voltage sag or voltage dip is occurring? Due to 20% of EV penetration will, for example, now the percentage of EV available is only 5% in India. If they have been increased from 20% or if we increase it to 60% also, our system can withstand. But what will happen is they will increase the range of voltage sag limit. What is the voltage sag limit? 230 volts plus or minus 6%. When you increase this more electric vehicle, this percentage tolerance has to be increased to 10%. Why? Because the load is constant, but how much load we are connecting to the system is extraordinary. So, and we can't say that we charge your electric vehicle only in college. We can't say that we charge your electric vehicle only at house. So, we don't know where we are going to charge your electric vehicle. Load is continuously varying and location is also continuously varying. So, they should able to withstand the sudden changes. So, the voltage magnitude tolerance will be changing if they are due to higher penetration of EV. Sir, what are the possible solutions? Possible solution is use voltage group charging. Never buy a charger of fast charging. Use only which type of charging? Level 1 charger, which is called domestic charger 3.3 kilowatt like Tata Nexon EV, and use only level 1 or level 2 charger. Don't go with level 3 charging. What is level 3 charger rating? 30 kilowatts for 30 for 1 minute for 30 minutes it will consume 30 units of power, where this cannot be tolerated by the grid, sudden changes. Okay, so you should not go for fast charging. You should use only domestic charger or class level 1 charger or level 2 charging methods, or improve your available grid technologies to smart grid technologies. Therefore, by having smart grid technologies or by charging with level 1 slow charger or level 2 charger, you can eliminate the problems created by electric vehicle in the decrement of voltage, where this is called voltage sag problem. So, what is voltage sag means? You see here, this is of 230 volts. When you connect this fast charging L3 charger, this voltage will fall down to 220 volts. What happened from 230 to 220? Voltage has been decreased. So, due to this decrement, it struggles with the problems of voltage sag problems, where this is called power quality problems. So, this we can mitigate by using what? Latest, we have to optimize our we have to optimize our grid to smart grid, and we have to optimize our way of charging to level 1 charger. So, you have to charge your electric vehicles best only at your house. Don't charge your electric vehicle at outside market, which is too costly again. So, that's how to overcome the problems of voltage sag, by properly having a smart grid, by properly having an slow charging. Next one, power loss. So, due to more EV penetration, what happens is uncoordinated charging. I already told. So, everyone will have their, for example, in our campus, let's say all our professors has bought 10 electric vehicle. Each electric vehicle has 30 kilowatt rated. All 10 into 30 is how much? 300 kilowatts load will be available at morning 9 o'clock. The college will not start. Why? Because complete load is consumed by what? The electric vehicles. Okay, so you should not use that uncoordinated charger. So they have to charge that electric vehicle only at after 4 o'clock. Then that way of charging is called coordinate charger. At 4 o'clock, no student will be there in the campus. Automatically, required amount of power will be there, and the demand on the system is also lower. Automatically, the system can handle the EV charger. Next one, power transformers to the long. If you transfer the power to long distance, this will also create which type of losses? Power losses. Okay, so better how to handle this problem of power losses is use coordinate charging technique. Mean charge your EV only at low peak hours, and when you have to charge your electric vehicle at night time when there is no load. Foreign countries, no, they will not turn on the washing machine, EV charger at morning time. They have a timer based in the app itself. They will set the timer at which time washing machine has to turn on, at which time dishwasher has to turn on. They have a timer based. So they will consume the power only at off peak hours. They will not consume the power at peak hours. Okay, so like that you have to use charge your EV only at night time or off peak hours. Next one, we have to use some microgrid technology or solar system to charge your electric vehicle. If you want to reduce the loss, how we can reduce the loss? So from here we are using the power. The power is coming from around 400 or 500 kilometers. Longer distance they are traveling. If they are traveling for longer distance, what they are going to create? Power loss. So how to reduce this power loss? You better charge your electric vehicle. You generate your power by using solar system and charge electric vehicle using that solar system. Automatically power loss can be reduced. Use latest technology of microgrid. Generate the power wherever the load is there. For example, we have the load in our campus. We are generating the power at the top of our building. We are directly consuming the technology, where this is called microgrid technology. So we have to use microgrid technology as well as a solar charger for our charging our electric vehicle, and charge your electric vehicle only at off peak hours will solve the problems of power losses. Next one, overloading of transformers. Why transformers are getting overloaded? At a time, heavy load around 300 kilowatt load will be available at 9 o'clock, where this is an increased EV load. 10 to 20% of EV penetration will create an overloading to the transformer. If you are penetrating more amount of EV, automatically it will overload your transformers. Or what to do? You try to maintain a level of EV penetration. So don't connect all the EV vehicles at a time. Use proper coordinate charger. If you don't have proper coordinate charger, you improve your power system to smart grid. You improve your power system to microgrid. You improve your power system to solar systems. Then automatically our electric vehicle can better handle the issues. Next one, power quality degradation. So what is this power quality degradation means? If more EVs are available, automatically they are basically of what? Capacitive nature and inductive nature. They will create more amount of harmonics. If more amount of harmonics and more amount of load is there, more amount of voltage sag or voltage dip will occur. So all this will create an high current to flow on the cable. If high current is flowing, then the capable limit, automatically the cable will burn off. So all these are the issues created due to more penetration of EVs. So what to do to reduce all this problem with the existing system is you try to maintain a level of EV penetration. So this is, I think, hope you are able to understand environmental effects of buying electric vehicle than beyond the limit, and what are the problems created by energy supplies. What are the problems created? First problem, voltage instability problem. Next one, harmonics. Next problem, voltage sag. Next one, power losses. Next one, overloading of transformer. Next one, power quality issues. What are the best ways we can solve all this problem? Better, you try to maintain a required amount of EV penetration. IC engine should be of 60% and EV penetration should be of how much? 40%. If you are increasing the EV penetration, you should optimize your power grid to microgrid. You should optimize your power system to smart grid. You have to optimize your power system with solar system. That's why government has to launch these projects of microgrid, nano grids, smart grids, as well as solar system charger. And we have to charge our electric vehicle only at which time? Night time rather than at morning time. Charging the electric vehicle at night time is called as which type of charging? Coordinate charger. And use only voltage group charging. What is meant by voltage group charger? Use only domestic charger or use level 2 of shopping mall charger. Don't charge your electric vehicles or don't have an fast charger. So which will also create an power quality issues to what? GENCO or energy supplies. Next, it can be solved. What are the possible ways we can solve from power? GENCO side, we have to use active and passive filters to eliminate the harmonic generated by electric vehicle. Use pulse width modulation chargers, which are a little bit more costly. If you use pulse width modulation chargers, harmonics may not be developed by EV chargers. And use coordinate charging. Already discussed. What is coordinate charging? What is a coordinate charger? Charge EV only at off peak hour, such a way that it will not create any voltage sag issues or harmonics at morning time. Okay. Next, what is the one more problem they are going to create? Voltage instability. How to handle this voltage instability? If more EVs are there, we have to automatically adjust the tap changing of the transformer. If you are unable to do of its automatic or manually, use a fuzzy logic, latest fuzzy logic controller based voltage control adjustment technique, or use latest smart grid. So now we have been saying everyone should buy electric vehicle. We are ready from customer side, from government side. What government should take the action to handle the environmental purchases of electric vehicle? What Genco has to do? They should develop their network as what? Microgrid, nanogrid, smart grid, as well as solar system they have to use. And we also should use only slow charging method. We should not use fast chargers at our house. And we are suggestible to use latest pulse width modulation chargers, and government also should use latest tap changing, automatic tap changing transformers, and they have to use an latest smart grid. So if you go to smart grid, all the problems are solved. And if you use latest transformer, all the problems are solved. There is no power loss, there is no overloading, there is no voltage sag, there is no voltage swell, there is no voltage instability, there is no overloading of transformer, there is no power quality issues. All these problems will be arrested only when which type of technique? Smart grid technology that government has to upgrade from their end. From our end, we are upgrading from IC engines to electric vehicle. They have to upgrade from normal grid to smart grid. So this is all about environmental effects created by electric vehicle on whom? Power generating companies. Okay, all these problems are created by what? Electric vehicle to whom? Power generating companies, and those are all the feasible solutions that to be developed by Genco or power generating companies. This is all about the environmental effects of electric vehicle on power generating suppliers. Okay, thank you.